Greetings, dear respected sir, ma'am. My name is Amruth Meday, and I'm currently studying in my third year mechanical engineering from Karuna Institute of Technology and Sciences. I will be presenting my project report, which I've carried out throughout this IST internship under the guidance of Dr. Sarkar with the College of Aviation Technology, Dhaka, Bangladesh. So the title of my project was to design next generation flying vehicle and its jet engine for commercial transportation civil aviation service. So as we all know that this was an IST remote internship, the motto of IST is work, experience, discover. So I'll be presenting this project report in these three parts: work, experience, discover. So first let's move on to work. So regarding the work, the first thing I did in this internship was to find out how did an aircraft actually fly, like what are the parts of an aircraft, or how do the engines of this engine of the aircraft work, what are the different flight phases of an aircraft. So the parts of an airplane. So the general parts of an airplane include a fuselage, wing, vertical stabilizer, horizontal stabilizer, wings, engines, and cockpit. So the fuselage or the body, it holds the entire payload together. It carries the passengers, the fuel, everything is situated inside it. The cockpit is the command and control center of the airplane, from where the pilot and the co-pilot operate the aircraft. The wing is responsible to generate the lift, and the vertical stabilizer is used to control yaw. Horizontal stabilizer is used to control pitch. The jet engine, it helps to generate thrust, which moves the airplane forward. Now, how wings of an airplane generate lift? So the geometry of an airplane wing is designed in such a way that the air on top of the wing moves faster than the air at the bottom of the wing. Now, as the air moves fast at the top of the wing, the pressure of the air decreases. So if you compare the pressure on top and bottom of the wing, there is a pressure difference between the two areas. Pressure difference between the two areas. Now this pressure difference, it creates a force on the wing that lifts the wing into the air. So as you can see in the diagram, this is the basic principle of how wings are able to generate lift. Forces of flight. So there are four basic forces of flight which operate on an airplane. The first is the lift, thrust, weight, and drag. Controlling the path of an airplane. So to control the path of the airway, the first, if you want to roll an airplane to the left or the right, the ailerons are engaged. Now the ailerons are raised on one side of the wing and lowered on the other side. So this creates a roll through which the airplane can maneuver. The pitch makes a plane descend or climb up and down. The pilot adjusts the elevators on the tail to make the plane descend or climb. Yaw is the turning of an airplane. So in order to yaw an airplane, the rudder is engaged to one side, which makes the airplane move to the left or the right. Now, phases of flight. So the phases of flight include the pre-departure. This is the preparation time of flight. The pilots will commence a walk around the airplane, do a visual inspection of the entire airplane to check for any abnormalities such as an oil leak, wear, tear, damages. Okay, the next is damages. Then we have the passengers who check in and board the flight. Then we have the clearance to taxi. Once the aircraft is boarded with passengers and loaded with cargo, all the doors are closed and pilots are given a ground clearance to be taxied to the runway. Takeoff. Then after the taxi, the airplane is taxied to the runway, from where it takes off and goes on to an initial climb. After that, it will commence the climb to the cruise altitude. It's basically the altitude at which the airplane is going to cruise for the major part of the journey. Then after they reach the cruise altitude, they'll be cruising at that altitude for quite an amount of time, and then the descent phase will start. So the descent phase is preparation to approach the runway. Then the airplane, they approach the runway, and ultimately they land back on the airport, and they taxi to the terminal. So this is the basic phases of a flight. Now the next thing is, how does a jet engine work? So thermodynamically speaking, a jet engine uses an Brayton cycle to function. Okay, so all jet engines, these are also called as gas turbine simples, work on the same principle. The air is sucked into the engine from the front of the fan. It is compressed, it is ignited, and whatever energy is released, that it is thrown back, shot back from the engine, which generates thrust. So what are the parts of a jet engine? So the first part of the jet engine is the fan. The fan is the first component in a turbofan. The large spinning fan, it will suck in a huge amount of air, which will be again sent to the second part of the engine, which is the compressor. Now the compressor this is the first component of the core part of the engine. The compressor is made up of a lot of fan blades attached to the shaft. These fan blades, they squeeze the air into smaller components in smaller areas, which then increase the air pressure. This results in increase of the energy potential of the air. The squashed air, which is then forced into the combustor. In the combustor, air is mixed with fuel and ignited. There are as many as 20 nozzles to spray the fuel into the airstream. The mixture of air and fuel catches fire. This provides a high temperature, high energy airflow. The fuel burns with the oxygen of the compressed air, producing high expanding gases inside the combustor. The turbine. The next part is the turbine. The high energy airflow coming out of the combustor goes into the turbine, causing the turbine blades to rotate. The turbines are linked to a shaft to turn the blades in the compressor and to spin the intake fan at the front. This rotation takes some energy from the high energy flow that is used to drive the fan and the compressor. Nozzle. The nozzle is the exhaust duct of the engine. This is the engine part which actually produces the thrust for the plane. The energy depleted airflow that passes past the turbine, in addition to the colder air that was bypassed from the engine core, produces a force when exiting the nozzle that acts to propel the engine, and therefore the airplane moves forward. The combustion of the hot air and cold air are expelled and produce an exhaust, which causes a forward thrust. The nozzle may be preceded by a mixer which combines the high temperature air coming from the engine core with the low temperature air that was bypassed in the fan. The mixer helps to make the engine quieter. So this is basically how a jet engine works and how an airplane is able to fly. Now we're going to come up with the design model of Lockheed Martin X-59. Now the special thing about Lockheed Martin X-59 is it is a research aircraft designed by NASA, designed for NASA so that they can study the feasibility of supersonic air travel. So the introduction and mission of this aircraft. For more than a decade, Lockheed Martin, Skunk and NASA have partnered to solve one of the most pressing challenges of supersonic flight, the sonic boom. After this aircraft is designed and manufactured, the aircraft will be flown over populated areas across the US and international regulators with statistical data to evaluate the feasibility of supersonic flight, to design new rules which would allow quiet commercial supersonic flight over the land, which would bring all of us one step closer to quiet supersonic travel for passengers around the globe. Now the specifications of the X-59 are given in this diagram. Okay, specifications, the diagram and the configuration of the entire aircraft is mentioned in this slide. Now the X-59 CAD model design. This is the basic CAD model design, which was designed and modeled by me uh, in the CAD software Fusion 360. So while designing the software, I realized the different meaning parts of the aircraft and why is there such a long boom. So basically the design is made in such a way that the energy created to the sonant boom is circulated around the body of the aircraft. Okay, so now we come over to the jet engine which will be used for this aircraft, which is the F414GE400. Introduction and mission. So the F414GE400 combines the proven reliability and maintainability because it has been already used by aircrafts before uh, with the predecessor for the F404 model, and in this particular engine model they have come up with some advanced technologies which will provide the Lockheed Martin X-59 with additional 35% more thrust and significant improvements in aircraft performance, survivability and payload. The advanced technology features includes full authority digital electronic control. This improves operational characteristics of the F414 engine, while advanced materials and cooling techniques improve performance and extend component life. The F414 enhanced engine incorporates additional technical advancements that can be retrofitted into the F414 to provide improved component capability for a significant reduction in ownership cost or up to 20% increase in thrust with improved specific fuel consumption. Now the specifications of the F414 is given over here. So we come over to the next part of this project report is the experience. So what is the experience I have gained through this project? So first of all, this is my first internship, and it is actually on remote. Before this pandemic started and all, I don't know there was a thing as a remote internship, but thanks to IST I was able to go through this remote internship. It was a pretty new experience for me because as I'm from a core mechanical background, and I had only very little knowledge of the aerospace field, so I was a bit scared, not scared, like I had a bit of concern of how I'll be doing this internship, but huge thanks to my guide. He helped me out throughout the experience. I learned how an aircraft flies, the jet engine, how a thrust is created, how the thrust is created. Moreover, I had really learned a lot while designing the CAD model of the X-59 Fusion 360, because this is the first time I have tried to model an aircraft in the software. Otherwise I only used to model parts for 3D printing and small mechanisms. I used a different form of modeling called foam modeling or B-splines in Fusion 360, and it was really fun to learn this new method. I really look forward to designing more aircrafts in the future. Okay, so the next part we move on to discover. So what I discovered with this internship is how huge the aerospace field is, like where I can pursue my further studies from. Being from mechanical background, it is quite challenging to decide upon which field you'll be choosing for your higher studies, like for your masters and all. There are so many options like manufacturing, structural designing, motorsports, and aerospace is a part of it in which I could venture into. And one of my main aim to join this internship was to see if I have the interest to pursue my master's in aerospace. And I will say yes, I have developed an interest. I may end up doing my master's in a branch of an aerospace company in the future. I discovered a lot about supersonic travel, like what the supersonic travel scenario was before, like with the Concorde and all, and how NASA is working to make supersonic travel true one day, which is more economical, which is more green fuel consumptions, and yeah, make it more feasible for supersonic air travel. So that was it for my project report. I would like to thank my guide for guiding me throughout this internship, for guiding me for this internship. I would like to thank IST Bangladesh and IST India for making this internship possible. Thank you.